Indian children with ADHD or neurological disorders lack personalized multimodal education support and standard text AI fails them. Hello everyone, today we are showing Katha Gemma, a voice-first retrieval augmented tutoring system built on Google's Gemma to support early childhood literacy, specifically aged 5 to 7 years across Bharat. Standard text UIs fail young kids, especially neurodivergent learners, and Katha Gemma acts here as an infinitely patient tutor that speaks, hears, and sees using structural state routing to keep children engaged. Let's start a new adventure in the application. The child is presented with a story card based on NCERT Barkha books. The child reads sentence by sentence using the text highlighted in real time, accompanied by automatic friendly voice narration. Our agent queries the local ChromaDB vector store using the sentence transformers to fetch curriculum aligned passages and matching illustrations and grounding specifically to Gamma's creativity so she never hallucinates. Young children often code switch, mixing native languages into English structures. So if a child responds, "Tell me a story about Peepo the panda in a candy forest," our local dictionary and Gemini 2.5 Flash translation loop immediately intercepts, normalizes the English-Binglish text, and update the attention tracker. If a child gets distracted for over 15 seconds, the tracker shifts state. Now, when a distraction or silence is registered, our state orchestrator pivots the UI into an active scavenger hunt quest. The screen transitions into a live camera view, asking the child to find an object or a target in their room. Once the child holds up a target, maybe a green leaf or a toy, and shows it to the camera, the vision encoder verifies it and unlocks an achievement badge in our local SQLite database. Finally, at the end of the story, the child completes all chapters and enters a celebration view. By using 4-bit NF4 quantization, Katha Gemma runs locally, requiring only up to 2 to 3 GB of VRAM, enabling cost-effective deployment on edge Android tablets and laptops in rural schools, providing standard literacy across without cloud latency or internet costs. Now coming to the architecture, we have used all possible specific sources, mainly for ears, eyes, and voice of the model. We have used speech whisper, then the Gemma vision used for the camera, and the touch bubble also has been provided in the application, along with the audio playback text-to-speech engine providing the output directly to the children. So the brain is residing in the user, been developed or by using the Chroma rack corpus. Now the core reasoning of the entire application is handled by Gemma. Gemma 4, specifically the E to B variant. However, we can plan to deploy it with the smaller Gemma versions on edge devices in future versions. So this is trained using local LoRa fine-tuning, specifically to output strict structured JSON values for the UI to render the specific output seamlessly. So the child can either see the audio or a camera popping up so that the child can show a particular device to the camera. So this all is carried by the ChromaDB outputting a structured JSON to the UI, which illustrates the front end seamlessly. Thank you.